students, today we are proceeding with our next topic, that is redox reaction. This word redox is made up of two words, that is first is reduction and other one is oxidation. Now from reduction we have taken RED and from the oxidation I have taken ox. So basically redox is the combination of two reactions, reduction and oxidation. So it is very important to understand reduction and oxidation reaction to understand the redox reaction. I have written two reactions. Magnesium plus oxygen is giving you magnesium oxide. Carbon monoxide plus hydrogen is giving you CH3OH, that is methanol. What is the difference in between these two equations? There is a very big difference. See, here Mg is added with the oxygen, so it is the oxidation. In any element when oxygen is added, the reaction is known as oxidation. But when in a compound hydrogen is added, what is it? It will be known as reduction. To understand these oxidation and reduction terms, I am just making a small table. It will help you in understanding the basic concept of oxidation and reduction. Now, first of all, I am talking about the oxidation. See, when we are adding oxygen or we are reducing hydrogen, it is known as oxidation. Another thing, when there is a loss of electrons from any element, when electrons are lost, that reaction will be termed as oxidation only. On the opposite hand, if we talk about the reduction reaction, it will be opposite to the oxidation. When there is a removal of oxygen or addition of hydrogen, or any element or compound is gaining electrons, it will come under the category of reduction. It's the basic concept of oxidation and reduction. If you are going to remember these two things, then you will never have ever any confusion between the oxidation and reduction. I am repeating again, when in any element oxygen as it is added or hydrogen is eliminated or there is loss of electrons, it will be oxidation. But when there is a removal of oxygen and addition of hydrogen, it will be definitely reduction. We are taking one more example so that you have clear idea about the oxidation and reduction. Now, as we are seeing, it is sodium, it is oxygen. Okay. Now what you are observing? Here oxygen is adding to the sodium. Yes. When we are adding the oxygen to the element, it will be termed as oxidation. Clear? Another example of oxidation. Copper. Copper plus oxygen is combining to give you copper oxide. Now, what you are doing? What you are observing? Oxygen is adding to the copper part and forming a new compound, that is copper oxide, and here oxygen is added to the copper. So it is oxidation. Clear? So I think oxidation is very much clear that in any element or in any compound when oxygen is added, it is oxidation. In fact, when you are removing the hydrogen also from any compound or any molecule, then also that reaction is oxidation. Now coming to the reduction part, we are going to take an example of reduction 2 so that each and every concept is clear. Magnesium oxide plus calcium is giving you magnesium plus carbon monoxide. Now what you are observing in this reaction? Here oxygen is removed, so it is oxidation reaction. Is it? No, it is wrong. When oxygen is removed, it is reduction reaction. Now in the second panel, carbon. Now in this, what you are observing, oxygen is added. When oxygen is added, the reaction is oxidation. Just keep in mind, redox reaction always occurs in pair. If there is a reduction reaction, then subsequently there will be an oxidation reaction too. It's the redox. So redox reactions are in a single chemical reaction, you will have both the reactions, oxidation and reduction. Now if we are talking about the electronics part, and I am going to clear that part also. I am taking the example of magnesium plus oxygen, that is giving you 2MgO. Okay. Now if we talk about the valency part, magnesium has 2 valence electrons, and we all know that in a reaction only valence electrons take place, and in oxygen you are having 6 valence electrons. Yes, oxygen has 6 valence electrons, and all these only valence electrons take place on the, okay. Now magnesium, when magnesium is having 2 valence electrons, so either it will take rest of the 6 valence electrons or it will give these 2 electrons. Why it is necessary? Because in the outer orbit there are always 8 valence electrons, so that an element should be in a stable state. So to be in a stable state, it has to give either to be 2 valence electrons or either have to take 6 valence electrons. But if we talk about the taking and giving part, these 2 valence electrons are very easy to give, but it would be very hard for the oxygen to give all these 6 valence electrons. So magnesium will give its electrons to oxygen and it will form 2MgO. Clear? Now I am taking one more example of electrons. It will be related to sodium. We have studied the equation of sodium. 4Na plus oxygen is giving you 2Na4, that is sodium oxide. Now we already know that oxygen is having 6 valence electrons. Now how much more electrons it has to take? It needs 2 more electrons to be in a stable state. Sodium has 1 valence electrons. Okay, so it is not possible to take 7 valence electrons, so therefore it will give its 1 valence electrons to oxygen, and here there will be 2 molecules of sodium oxide. Now I think this is very much clear. Now coming to the next part of this, what is oxidizing agent? Here we have talked about the oxidation reduction, but what is oxidizing agent? Now I am giving you one example. 2CO plus H2 is giving you copper plus H2O. Now you have seen this, copper oxide is giving you copper, so oxygen is removed, and when we are removing the oxygen, it is a reduction reaction. And what you are seeing in the hydrogen part, hydrogen is gaining the oxygen atom, so it is oxidation. So we have seen in this equation that in a single equation we are having both types of chemical reaction, that is reduction and oxidation. Therefore it is a redox reaction. Now oxidation किसमें हुआ? हाइड्रोजन. रिडक्शन किसमें हुआ? कॉपर ऑक्साइड. नाउ नेक्स्ट थिंग्स कम, ऑक्सीडाइजिंग एजेंट. Now which one is the oxidizing agent? Oxidizing agent is copper oxide. Yes, oxidizing agent is copper oxide. Now why it is oxidizing agent? Because it is helping in reducing the copper oxide. Clear? Now what is reducing agent? Reducing agent is hydrogen. Now why it is reducing agent? Because it's the hydrogen who is taking this oxygen part, therefore copper is reduced. Now next question. Hydrogen sulfide plus chlorine is giving you sulfur plus HCl. Now we are seeing that it is hydrogen is removed. When hydrogen is removed, it is oxidation reaction, and when an element is gaining the hydrogen, it is reduction reaction. The thing is, what is oxidizing agent? Always keep in mind the element, the compound, the molecule which goes under the reduction reaction will be the oxidizing agent. Now reducing agent, which compound that goes under the process of oxidation will be the reducing agent. So substance which gets oxidized is the reducing agent, substance which gets reduced is the oxidizing agent. So now we are coming to the redox reactions. We are taking more examples of redox reaction. Basically, if we talk about the daily life, the normal process of redox reactions we can see in photosynthesis or during the charging of our mobiles, battery mobiles. Now the next example is here we are seeing carbon atoms, and carbon is gaining oxygen. When any element is gaining oxygen, it will be known as, the reaction will be known as oxidation. Now here it is reducing. Why? Because oxygen is removed in this compound, so it is reduction reaction. And we have already said that when in a reaction, oxidation and reduction reactions are simultaneously taking place, the reaction is redox reaction. Now second example, we are taking ammonia plus bromine, that gives us nitrogen plus hydrogen bromide. Now what we are observing that in ammonia hydrogen is removed, and we have already mentioned that whenever hydrogen is removed from any compound, it will be known as oxidation, and whenever hydrogen is added to any compound or any element, it is known as reduction. So it's a basically small concept that in a redox reaction, oxidation and reduction reaction simultaneously take place. In oxidation reaction, we are adding oxygen or removing hydrogen, and on the opposite side, in reduction reaction, we are removing